All right, so this one we continue with geometric series. We're gonna work out that, all right, is the sum. So what telling me, they say when you take that, which is in bracket, and then times into that, the answer will be equals to what's on the right-hand side, okay? So my mind tells me, if I were to pretend these were the terms, these terms, I can add those terms and then get the answer. But break it into two. Listen, break it like this. Have this first this box, and then also have the blue box. So keep the blue box alone. The blue box does not form a pattern. What forms a pattern is a red box. Work out the sum of the red box. That's what it means. Do the sum of the red box. Once you get the answer, multiply it by 1 minus x. That's all you have to do. Then you'll get that. So, what am I saying? Momentarily, forget about the blue box. So you pretend it is not there. It does not exist. We kind of like, let's pretend this was not there. Let's just work out the sum of that. Once we get the answer, let's bring back the blue box, multiply by that. That's what it means, nothing else, all right? Because that will be our left-hand side. I won't even write left-hand side. But I want you to look at this one. This is x to the 2. Let's reverse. X to the 1. It's x to the exponent of 1. There is a 1 there. How about the next one? It should have been x to the exponent of 0. There we go. Because that's why we're getting a 1. Now, this is going to help me. I'm looking at the red box only. Come on, forget about this one momentarily. Please, just chill. Look. When I look at that x here, this one, it's x to the 1. That x to the 0, forget it now. Just pause. Shut your mind from it. Just say, this is x to the 1, x to the 2. So if this wasn't there, this will be the first term, and the exponent says 1. This will be term number 2. The exponent becomes 2. So that means if you keep on going, by the time you get here, this will be term 99. If I were to start from here, but you've got that one, the 1x to the 0. So let's just remove it. So that means everything that I'm underlining in blue, it's 99 terms plus that one extra. So there are 100 terms. For the red box, n equals to 100 terms. So we're just doing the sum of the first 100 terms. So which means I can write the red box. Let me use red for red so that you can see. So that means I'm going to do the sum of the first 100 terms. But you see, that represents the red. How about the blue portion? The blue portion, then I can say, but this thing, I'm going to have to multiply it by 1 minus the x. All I need to do is to solve the red giza. That's all. That's all. Solve the red one. Then we will be in good terms. That is exactly how I'm going to do it. So I'm going to keep that one in bracket, x, no, 1 minus x, 1 minus x like that. Then I'm starting to do the substitution on the red. All right, so let's just do that. Substituting on the red, the first term is 1. So I'm having 1 into, what is the r? It will be x divided by 1, which is x, to the power of n, which is how much? 100. Then minus what? The 1. I'm doing the substitution. Then divide that by x minus the 1. So I can put that in bracket because you see that blue. and that red, they can cancel if I write them in a correct order. So this represents my left-hand side. Is my left-hand side. So choice is mine. I can change the red one or change the blue. I'm going to change the blue. Changing the blue, this is what happened. I'm going to reverse the order and take out negative as a common. So minus into, now we now have x minus 1 in the parentheses. The red equation will remain as is. So I'm just going to copy it and just bring it down there. So there we go. So now you can see, because remember, this is our left-hand side. Left-hand side. So that cancels with that. Remember, we still have a negative here. So what are we left with? We're left with the minus, that one there. And we're left with this thing that is red, which is x to the power of 100 minus 1. Of course, all of that equals to our left-hand side. There we go. Now, you see now, if I take this minus, multiply into the brackets, I'm going to have negative x to the exponent of 100 plus the 1. This equals to my left-hand side. But if I want to change the order, if I want to write the positive 1 first, so it's 1, then and then followed by negative x to the exponent of 100. That will give me my left-hand side. And when you look at it, it does look like the right-hand side. So now we can write QED, which means quite easily done. Qed in Xhosa, qedile, meaning we are done, we are finished. I'm just a student. Thank you. The God of maths is Jesus. Thank you. We're done, my